Have you ever wondered why you can't just feed an entire novel into an AI and have it get it? Well, you've stumbled upon one of the biggest walls in all of AI. Today, we're going to look at the incredible engineering that's tearing that wall down and turning AI's memory from a bottleneck into a superhighway. So, here's the plan. First, we're going to really dig into what this big problem is, the bottleneck. Then we'll explore 3 totally different ways engineers are trying to solve it. We'll pit the top methods against each other, and then we'll wrap up with a playbook for how all this stuff actually gets used in the real world.
All right, let's get right to the heart of it. This is the core challenge, and trust me, it might seem small, but its consequences are absolutely massive for what AI can and can't do. I mean, it's a fair question, right? You want to feed it huge documents, a whole programming project, maybe a decade of financial records. But whenever you try, the whole system just grinds to a halt. And the reason for that is a really deep, fundamental limit on how these models actually pay attention.
The bad guy in our story has a pretty nerdy name, the quadratic scaling problem. But here's all it really means. If you double the length of the text you give an AI, you don't just double the work, you quadruple it. And the memory needed? That quadruples too. It just explodes, creating this computational brick wall that gets exponentially harder to break through.
Now, you might be thinking, okay, so we just need faster computer chips, right? But it's not actually about the raw calculation speed. The real problem is physical. It's a traffic jam. It's what we call I/O bound. Imagine the GPU has a giant library. That's its good, kind of slow memory. And it also has a tiny, lightning-fast disk right next to the processor. The slowdown comes from having to run back and forth between the library and the desk. It's all that travel time that's killing performance.
Okay, so we've got this massive traffic jam problem. How do we fix it? Well, some really clever engineers have come up with 3 completely different strategies to clear the road.
You can kind of think of these as 3 different mindsets. Path A is the hardware whisperer approach. It's all about making the process of moving data way smarter without changing the math at all. Path B is the pragmatist. They ask, what if good enough is actually better? And they approximate the math to make it easier. And then Path C is the architect, who says, let's just throw out the old blueprint and design something new from scratch.
Let's start with Path A, because this one is, well, kind of mind-blowing. It's a solution called FlashAttention, and the craziest part is that it gets the exact same answer, just ridiculously faster.
Okay, let's go back to our library analogy. Standard attention is like running back to the library shelves for every single word. It's exhausting, and most of your time is spent just running around. FlashAttention is totally different. It's like going to the library once, grabbing a whole armload of books, taking them to your super-fast desk, and doing all the work right there. It fuses a bunch of little steps into one big, efficient move. Less running, more working. That's the secret.
So, did it work? Oh, absolutely. The very first version of FlashAttention sped up the training for a model like GPT-2 by up to 3 times. And get this, the result is mathematically identical. It's a pure speed-up, no tricks. But they didn't stop there.
Because right after that, FlashAttention 2 came out and doubled the speed up again. It just proves how much performance was being wasted, just left on the table by that data traffic jam. This is what happens when your software is designed to be really, really smart about the hardware it's running on. Okay, so FlashAttention is incredible if you need perfect bit-for-bit accuracy. But what if you don't? This brings us to our other 2 paths, the ones that are willing to make a trade. A tiny bit of accuracy for massive gains in efficiency. So you've got 2 main approaches here. Performer is all about a clever math trick. It finds a shortcut to a good enough answer, and that shortcut lets it scale linearly. It's a total game changer for memory. Then there's Longformer, which changes the design. It argues that not every word needs to look at every other word. So it uses a local window of attention plus a few special spotlight words that can see everything. Think of it as a spotlight instead of a floodlight. And speaking of architectural changes, look at this. Transformer XL can achieve just insane speedups. We're talking up to 1,800 times faster in some cases. Its trick? It caches or remembers its previous calculations.
So when it moves to the next chunk of text, it doesn't have to start all over again from the beginning. It's brilliant.
Okay, so we've got all these incredible tools in our toolkit. You have the exact and fast approach and the approximate but super scalable approaches. So if you're building something, how on earth do you choose? Let's lay out a quick playbook.
And this really is the key question for anyone working in this space, isn't it? There's no one-size-fits-all answer. It's always a game of trade-offs. What do you care about most? Is it perfect accuracy? Is it handling massive documents? Is it pure speed?
This table really helps break it down. You see FlashAttention up top? Its attention is exact, but it's still quadratic. That means it's your champion when quality is king. Now compare that to Performer. It's approximate, but in exchange you get that beautiful linear scaling. That's your go-to when you're memory constrained and dealing with something epically long. Longformer and Transformer XL, they each have their own special use cases, perfect for specific jobs like document analysis or streaming text.
We can actually simplify this into a really clear decision tree. The first question you always ask is, do I need perfect accuracy? If the answer is yes, then your choice is simple. Use FlashAttention. If the answer is no, you move to the next question. What's my biggest pain point? If it's memory, you try Performer. If you're building a system to analyze long documents, Longformer is your friend. And if you're generating text continuously, Transformer XL was literally built for that. See, it's a logical process.
But here's the final and maybe the most important twist. In the real world, the production models that millions of people use every day, well, they don't just pick one of these. They combine them.
Yeah, production models are hybrids. They're like a greatest hits album. They'll use something like FlashAttention as the foundation, because it's so fast for pre-training. But then, for inference, when we're actually using the model, they layer on other clever tricks. Things like multi-query attention, to drastically shrink the memory needed. Then they'll add methods like rope scaling to stretch a model's understanding to even longer text without a full retrain. It's not about finding one winner. It's about building a whole championship team of techniques.
Look, cracking this attention bottleneck isn't just some obscure engineering footnote. It fundamentally changes the game. It unlocks doors to solving problems we thought were impossible just a few years ago. So the really big question for all of us is this. Now that AI's memory is becoming practically limitless, what are we going to ask it to do?